Welcome. This lesson is over box plots. So let's go over what we remember from measures of spread. So we are given some numbers. I believe they are in sequential order: 62, 63, 64, 64, 70, 72, 76, 77, 81, 81. How do you find the median of this? Well, what is the definition of median? Median is where you have to figure out which number, put the numbers in sequential order, and figure out which number is in the middle of it. So let's cross out the least and the greatest until we can figure out which number's in the middle. So I see 70 and 72. The number in the middle is 71, or the median. We could add them up and get 142. Half of it is 71. Or could we just write a number between them? What's between 70 and 72? 71. Quartile 1. Quartile 1 is the lower quartile. What is the lower quartile? Well, there are 5 numbers. So if this is the median right here, there are 5 numbers in the lower quartiles. So which one is in the which one is the quartile 1? It is 64. Which number is in the upper quartile? It is 77. So we have 64, 77. So quartile 1 is 64. Quartile 3 is 77. And what is the interquartile range? That means if you look at a quartile, what is the range? It ranges from 64 to 77. So how far is it from 64 to 77? It is 13 numbers away. Let's check our answer through here. If you look here, we have the lower half and upper half. So 71 is the median. So the lower half includes the numbers 62, 63, 64, 64, 70. And so the lower quartile, or the quartile 1, is 64. While quartile 3 is 77. And so interquartile range ranges from 64 to 77. What if the question was, what is the spread or the range of the entire set of data? That would be from 62 to 81. All right, so you're going to be given some numbers. I would like you to put these numbers on the number line. But before we do that, we're going to, so we have some numbers right here. So let's look at our numbers. So what is the minimum? The minimum is 0. What is the maximum? It is 35. What is quartile 1, quartile 3, median? Let's find the median first. So let me use my highlighter so I can figure out which number is in the middle. This, you can tell the numbers are already in order. What you're going to be doing in class is you're going to be cutting them out, and then you will have to put them in order. So it goes right here. So the median would be 4.5 or 4.5. That'll be quartile 2 also. So quartile 2, or the median, is 4.5. So what numbers are in the lower half? 0, 1, 2, 3, and 4. Of these numbers, which one is the quartile 1, or the median of the lower half, or the lower quartile? It is 2. The upper numbers, upper half, is 5, 6, 9, 12, and 35. So what is quartile 3, the median of the upper half, or upper quartile, or quartile 3? It is 9. And so in here, it's time to make our box plot. So the way you make the box plot is you need to know these 5 important things: minimum, maximum, median, quartile 1, and quartile 3. From this, you will draw dots. So the minimum is 0. So find 0. It's right here. Draw a big dot for 0. The maximum is 35. So it's right here. Draw a big dot for 35. So this is the minimum. This is the maximum. If you want to label it, you can. So let's go. This is the minimum. This is the maximum. Then where's the median? The median is 4.5. So that goes right here. So let's label that. That's the median. Another way to describe that would also be quartile 2. So next one, the quartile 1 is 2. So we need to draw a dot for that one. Quartile 2 Quartile 1 is 2, so I draw a dot for that one. And then quartile 3 is 9, so draw a dot right here. So quartile 1 is right here, quartile 3 is right here, and median or quartile 2 is here. So now it is time to make a box plot. So these are called the tails. So the minimum connects with quartile 1, the maximum connect with quartile 3. Then you draw a box around the quartile 1 to quartile 3, and then you draw a line going down. So this is called a box plot. A box plot is made of 5 numbers, a minimum, a maximum, quartile 1, quartile 3, and median. So if it is broken into quartiles means like quarters. It's broken into 4 parts. So each part of this has 25% of the numbers. That means there are 25% here, 25% in here, 25% here, and 25% here. You may say, but this is so much longer. So this one there are more numbers here. No, think of quartiles as cuts. If I get my little pen and I cut it right here at 2, I cut it at 4.5, and cut it at 9, there are 2 numbers in each quartile. So 0, 1 is in this quartile. 3 and 4 is in this quartile. 5 and 6 are in this quartile. 12 and 35 are in this quartile. So that's why 2 out of 8 numbers, or 25%, are in from quartile 3 to the maximum. So for example, if I ask this question like, what percent of the numbers are 2 and higher? So if we look here, 2 and higher, 25, 25, 25, 75%. You don't trust. Yeah. And then, you might ask, what percent is from 4.5 to 35? That's 25, 25, 50% of the numbers are here. Another way to describe this is the shape of it. How would you describe the shape of it? Is it symmetrical? Symmetrical means like this one. The left half looks like the upper half. The lower half looks like the upper half. Definitely not symmetrical. Is it skewed to the left? That means, is it longer to the left side? No, definitely not. Is it skewed to the right? Yes, it is. Do you see on the right side, there's so much longer to tell. It is skewed to the right. All right, so now we are going to be practicing now. So how many hot wings can each student in this class eat in 5 minutes? So in this one, let's put the numbers in order first of all. So let's see, I see 10 and 11. I see 12 and 14. 15, 17, 19. Let's find the median. So the median is 14. So I'm going to write that down, 14. The lower half is 10, 11, and 12. So the median of the lower half is 11, which is the lower quartile, or quartile 1. The median of the upper half is 15, 17, 19. So 17 is the median of the upper half, or quartile 3. The minimum is 10. The maximum is 19. So let's draw a dot for each one. So we need to draw a dot for the minimum, 10. The maximum is 19. And you know what? I'm going to label this minimum, maximum. 14 is the median. 11 is quartile 1. And 17 is quartile 3. So now let's make a box plot. These are the tails. And then we draw a box around here. All right, so so in this one, label the percentages. 25% goes here, 25% goes here, 25% goes here, 25% goes here. Again, these are the cuts. But as these are cuts, as you can tell, there's one number, one number, one number, one number. So that's why 25%. So if I ask you the question, what percent of students ate 11 or more hot wings? How would you answer that? 25, 25, 25, 75% of the students ate 11 or more hot wings. What's the interquartile range? So interquartile range is the quartile ranges from 11 to 17 or 6. If I ask you what is the spread is from 10 to 19, which is 9. Is this symmetrical, skewed to the left or skewed to the right? You know what? If you look at this, there's 3 here, 3 here. It's a little more to the right, but you know what? It's pretty fairly symmetrical. Not exactly, but if I had to estimate, it's more closer to symmetrical than skewed to the left and skewed to the right. Let's try one last example of this. So let's put these numbers in orders. We have 2 8, 1 8, 2 9s, a 10, 11, 12, a 13, and a 15. So we have 4, 8 numbers, and I have 8 numbers here. So let's find the median. Let me get my highlighter. So the median is 10 and a half. The lower half is 8, 9, 9, 10. So what's the median of the lower half? 9. So that's quartile 1 is 9. The median of the upper half is 11, 12, 13, 15. So it's 12 and a half. The minimum is 8. The maximum is 15. That's 15. So let's draw our points. So 10 and a half, that's our median. You could call that quartile 2 if that's what you choose. The quartile 1 is 9. Quartile 3 is 12 and a half. 8 is the minimum. 15 is the maximum. Let's make a box plot. These are the tails. And then we draw a little box around here. And that is our box plot. So what is the interquartile range? The quartile ranges from 9 to 12 and a half. It goes from 9 to 12 and a half. So how far is it from 9 to 12? 10, 11, 12, 3 and a half spaces away. 1, 2, 3 and a half. So let's label our percentages: 25%, 25%, 25%, 25%. Again, why? These are the cuts. There's 2 numbers in each cut. So if I ask you, what percentage of numbers are less than 9? 25% are less than 9. 8 and 9 out of 8 numbers. 2 out of 8, 1/4 is 25%. Is it symmetrical? Not really. The tail is way longer on the right side, so it's skewed more to the right. Right here, skewed to the right. So we are going to answer the question. So now, what if you're given the box plot itself? Can you find the 5 parts of it? This is the minimum. This is the maximum. This is quartile 2. This is quartile 1. This is quartile 3. So minimum, the least is 20. The greatest is 40. Median is 30. Quartile 1 is 25. And quartile 3 is 35. And then let's put the 25. 25% goes here. 25% goes here. 25% goes here. 25% goes here. Oh, I already have our labels here. So what's the interquartile range? It ranges from 25 to 35 or 10. So what if my question was, these are the number of books 20 students read during a summer vacation. What percentage of students read 30 or more books? 30 or more, 50% of the students. And you know what? This is pretty symmetrical, if I do have to say. It's pretty symmetrical. The left half looks like the right half. So here's another example. So let's do minimum goes here, maximum goes here, the median goes here, quartile 1 goes here, quartile 3. I like drawing the dots here, so it makes it easier for me to see. 25% of the information goes here, 25% goes here, 25% goes here, and 25% goes here. Which choice shows a set of data that could be represented by the box plot shown? So the minimum is 10. They all have it. Shucks. The max is 20. Oh, they all have it. Shucks. The median is 17. So let's see which one does not have that. 4. Find the median. So 17. 17. 16. C is out. Yes. So we have one process of eliminated out. So it's either A or B. The quartile, the median at the lower half is 12. 12, 12. Shucks. The median at the upper half is 20. Oh, it's this one. So B is the answer. Here is the median at the upper half is 21. So now that we understand, so here are some questions. So which statement about the box plot is not true? 25% of the data are above 20. That's true. Above 20, 25%. That's true. The range of the data is 18. It ranges from 10 to 28. That's 18. That's true. The interquartile range is equal to the interquartile range is equal to the range of the fourth quartile. So interquartile range is from 12 to 20, which is 8. The fourth quartile, which is right here, goes from 20 to 28, which is 8. That's true. 11 and 13 are part of the second quartile. 11, no, that's part of quartile 1. 13 is part of quartile 2, so that's false. All right, now that we understand that, let's get to the seventh grade part of the lesson. In seventh grade, your part of the lesson will be how to compare two box plot. So it's just like sixth grade, we just introduce what box plots are and interpret it. But in seventh grade, now that you know what box plots are, can you compare the two information? So what is the median of both plots? Well, first of all, let's label it. This is the minimum. This is the maximum. This is the median, or quartile 2. This is quartile 1, or quartile 3. Let's label the B, minimum, maximum, median, quartile 1, quartile 3. What is the median of both plots? 70. Which plot has a smaller range? Well, in this one, it goes from 50 to 100, which is 50 away. This goes from 40 to 100, 60 away. So A, because it's only 50 away. Which plot has a greater interquartile range? So quartile ranges from 65 to 80. That's 15 away. Here, it goes from 60 to 85. That's 25 away. So B, 25 away. What percent of the data? Ooh, we should have written a percentage here. 25%, 25%, 25%, 25%, 25%, 25%, 25%, 25%. What percent of data in plot B is between 60 and 85? 50%. Two quartiles. What percent of the data in plot A is greater than 80? 25%. Which plot has a greater variability in the bottom 50%? So let's look at the bottom 50%. I mean, variability means more variety of numbers. So it goes from 50 to 70, but this one goes from 40 to 70. So it's B because it has a larger spread, a larger range. And the last thing we're going to do is, now that we understand how to compare a little more, is you're going to be working with your group and figuring out this, how Mrs. Turner's students were asked to study box plot representing the average monthly temperature for Honolulu and Las Vegas during 2013. Each student wrote a statement comparing the temperatures of the two cities. Determine whether you agree or disagree with each of their statement. Explain your thinking. So before I do that, I would like to, this is minimum. This is minimum. This is maximum. This is the median. This is quartile 1, quartile 3. This is the minimum. This is the maximum. This is the median. This is quartile 1, quartile 3. You know what? I'm going to blow up this screen. Yeah, much better. Hopefully you see this even better. So the median, let's look at what Marcus said. The median for both cities are very close. Median are very close. What do you mean they're close? Oh, there is less than a 10 degrees difference between them. So the median here is like 60. So Las Vegas, the median is like 68. In here, the median is like 70. Honolulu. I should use the blue pen. Oh, I don't have any pens here. So Honolulu is 77. So from 68 to 77, that is 9 away. So that's true. So I guess I do agree with him. Kylie said, most months in Las Vegas have average temperatures between 68 and 86. So here's 68 to 86. Since the third section is the longest. Wait, first of all, if you remember right from me, each quartile is worth 25%. Only 25%, even though this is the longest part, only 25%. That means 3 out of 12 months, or 1/4 of the year, goes from here. So I disagree with her. Honolulu has a greater spread in temperature because its median is higher. But first of all, the spread is only from 73 to 82. The spread is really short because if you've ever been to Hawaii or any Caribbean islands, it's always the same temperature. It's always a nice tropical temperature. It doesn't get really hot or really cold. It's a very nice temperature. Like Las Vegas in the wintertime gets really cold, but in the summertime, oh God, it's really hot. So I kind of disagree with her or him, and that is how to compare box plots.